Hi there, in this video clip I want to talk about the identification of cations, some metal ions. They give you a unknown powder and say, what do you think that contains then? Well, the first test you can perform is the flame test. And what I do is I take a very fine chrome nickel piece of wire, dip it into concentrated hydrochloric acid. That completely cleans it up, and then I put my cleaned nickel chromium loop into the powder, and then I put that loop containing a little bit of the unknown powder into the flame of a Bunsen burner, for example, and I get different colours: lithium, sodium, potassium, calcium and copper. Copper, lithium ions, sodium ions, potassium ions, calcium ions 2+, and copper ions. When I subject them to a flame test, different colours are seen. This is crimson red lithium. By the way, that's a deep red. Sodium, yellow or amber flame, coloured flame. You actually see it in the flame. Potassium, lilac, that's pale purplish. Calcium ions, brick red. And copper ions, green, or blue. The flame test identifies some metal cations. I've just said there that you burn these or put these compounds containing copper or whatever I've just been through into a flame. There's a device called flame photometry, a flame photometer. This is a device, it's a piece of apparatus. You take your sample, heat it up, and you've got an analyzer inside it, a spectrometer which analyzes the colours produced from burning those compounds. Remember from your physics days, well, you probably don't because maybe you're not doing it, but the colours of the visible spectrum go: Richard of York gave battle in vain. Richard of York gave battle in vain. I'm going to change those around so that it goes in a different order. I'm just going to rearrange it. VIB, GYOR. These are the colours of the electromagnetic spectrum in the visible part of the spectrum. The wave length is about 400 nanometers to about, let's say, 800 nanometers. So I've put those chemicals containing those cations into a photometer, a flame photometer, a flame spectroscope, and would you believe this? you get a spectrum or lines in the spectrum. For example, potassium would produce a line around that part of the spectrum. That would be potassium. Bluish or greenish, that would be copper ions. Yellow, sodium ions. Crimson, lilac here, crimson there as in lithium round there. So I've done that, haven't I? Copper, one more, potassium, I know I just can't think about it. Okay, something like that. And that is the principle of flame photometry. Let's look at some other tests to identify cations. And I can use the principle that when I add a solution of sodium hydroxide to a solution containing an unknown cation, it forms a precipitate. So this is what I'm saying. I'm taking a test tube that containing X in solution. I'm going to add to that a solution of sodium hydroxide, and it produces a precipitate. There's the solid being precipitated out of that solution. Depending on what ions that contains, I get a different coloured precipitate. For example, aluminium ions with the hydroxide ions produce a white precipitate. Calcium ions with hydroxide ions produce a white precipitate again. And if I took copper ions with hydroxide ions, it produces a greeny blue precipitate. And if I took something like ions with hydroxide ions, it produces a greeny or pale green precipitate. Hello, I'm running out of space, and let's take iron 3, Fe3 plus hydroxide ions. It produces a reddy brown, let's call it brown, produces a brown precipitate. Magnesium, hello, I've run out of space here, let's change it to that, Mg. Magnesium ions react with hydroxide ions, produce a white precipitate of magnesium hydroxide. So we've looked at flames produced by cations, colours, and we've also looked at the precipitates formed by adding sodium hydroxide solution. I'll be looking at more of these at a later date, but they are simple tests for the identification of metal cations. Simply adding a solution of sodium hydroxide and looking at the flame tests and
in the lab, like I said, you've done these wet air tests, but you can use an instrument, flame photometry, flame spectroscopy to identify very small amounts of those ions.